Determine the length of SK in terms of P, Q, and alpha. Let's go to our sketch and identify SK. We have SK right here. We're supposed to find the length in SK in terms of alpha, which is this angle right here, P, which is this side ST, and Q. What is this Q? Let's go ahead and read our question statement and figure it out. So we are told that in the diagram, ST and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. Angle TSK is equals to alpha, TS is equals to P meters, and the area of triangle STK is Q meters squared. Okay, so we have the area of triangle STK, which is equals to Q. So somehow we have to use the area, because how else can you get Q if you're not using the area? Okay, so let's see if we can use the area of triangle STK to find SK in terms of P, Q, and A. If we go ahead and try that, we're going to have the area of triangle STK being equals to a half. We need two sides and one angle between the two sides. We have ST, right? So multiplied by ST multiplied by SK, sine of the angle in between the two sides, which is alpha. So sine of alpha. So what is the area of triangle STK? We know it to be Q. A half. What is ST? ST is P. SK is what we are interested in, sine of alpha. It should be easy to see that SK will be equals to Q divided by 1 divided by 2 P sine of alpha. This is obviously equals to 2Q divided by P sine of alpha. So this is SK in terms of Q, P, and alpha. 7.1. Let's see if we can do 7.2. So 7.2, we're supposed to show that RS is equals to 2Q tan of beta divided by P sine of alpha. So let's go ahead and take a look at our triangle. This side in dotted lines is parallel as K. Why are we saying that? Beta is the angle of depression. So this angle right here is beta. Okay, we want to find RS in terms of Q, P, alpha, and beta. If you look at triangle RSK, we have a right angled triangle. So we can use tan, cos, and sine. We can use our trig ratio. In our solution, we have tan of beta. Okay, so it makes sense for us to start by trying tan and see if we get to the correct answer. So we're going to have tan theta being equals to the opposite divided by the adjacent. This is in triangle RSK. Okay, so we're going to have tan of beta being equals to the opposite, which is RS. So tan of beta is equals to RS divided by the adjacent. The adjacent is SK. Okay, so we have SK. So if we cross multiply here, we're going to get RS being equals to SK multiplied by tan of beta. But what is SK? We determined the SK in 7.1. SK is equals to 2Q divided by P sine of alpha. So if we replace SK with that, we are going to have 2Q divided by P sine of alpha multiplied by tan of beta. So this is just equals to 2Q tan of beta divided by P sine of alpha. Exactly what we are required to show. That is 7.2. Let's take a look at 7.3. Calculate the size of angle alpha if angle alpha is less than 90 degrees. Okay, we are told that RS is equals to 70 meters, P is 80 meters, Q is 2,500 meters squared, and beta is 42. So let's use the equation in 7.2, because in that equation we have RS being equals to 2Q tan of beta divided by P sine of alpha. In the information we have, we are given the length of RS. We are given Q, the area. We are given the angle beta, and P, right? P is said to be equals to 80 meters, and we are looking for alpha. So if we use this equation, we are only going to have one unknown variable, which is what we're interested in. Okay. So if we go ahead and cross multiply and divide, making sin alpha the subject of the formula, we're gonna have sine of alpha being equals to 2Q tan of beta divided by P multiplied by RS. Okay, so we're gonna have alpha being equals to sin arc of, so let's go ahead and substitute. We have 2 multiplied by Q. Q is 2500 multiplied by tan of beta. Beta is 42, okay? And then we're dividing everything by P multiplied by RS. P is said to be equals to 80 meters, and RS is equals to 70 meters. So it is just a matter of putting that in your calculator. And when I do that, I'm getting 53.51 degrees. So that is the size of angle alpha if alpha is less than 90 degrees.